Assalamualaikum and hi to everyone. Thank you for watching this video. So in this video, we continue on another chapter, chapter number 3, which refer to the operating system concept. So in this chapter 3, I will divide it into 3 parts. The first part, we will talk about the process involved. Okay. So we will learn about the processes under chapter 3. Okay, process concept. And then after that, we look for the process scheduling, operation of the processes. Okay, and then we continue on the inter-process communication, the example of the IP system and the communication in client-server system. So at the end of this chapter, you should be able to know what is the process involved in the operating system, what are the program, the job, the scheduling part. Okay, the first part is to introduce the notion of a process, mean a program in execution, which form the basis of all computation in the computer system. Second, to describe the various features of the processes, including the scheduling, creation and termination, and the communication. So when we talk about the communications, we need to establish and then we need to end the communication. That's why it include the creation and termination. Number 10, to explore the inter-process communication using shared memory and message passing. And number 4, to describe the communication in the client-server system. So these are the objective for chapter number 3. Then let's go to the first part. We go for the process concept. So an operating system execute a variety of programs. Program can be identified by two terms that we call as jobs and tasks. So batch system is referred to jobs and time shared system is referred to the user program or the task. Okay, batch system is job. The analogy is just like if you during your school's day you are in the batch SPM 2010 2015 for example. So it's batch by batch, and the production flow in the production flow also the product will be produced batch by batch. So the concept quite similar like this one. We have the batch system. In the batch system, we have the several jobs. Okay. In our textbooks that we refer for this subject, they use the terminology of job and process almost interchangeably. So process is referred to the program in execution, and process execution must progress in sequential fashion. Okay, for multiple parts, the program codes also called the text section, and then current activity including the program counter, processor, registers. Stack, this part you can refer to the memory architecture. We have the stack, we have the text section or code section. Okay, for the stack is contain the temporary data like the parameter function, the local variable, okay, and then the return addresses. That for the stack section. And then we have the section that we call as data. So at this section is contain the global variables, and we also have the heap section. So heap section is contain the memory dynamically allocated during the runtime. Means let's say your program have the runtime, so we put under the heap memory. Okay. Program is a passive entity stored on the disk. Okay, this is actually is a program that can be executed, but it's passive and then just stored in your memory. Process is referred to the same program but it's active, means it's executable. So program become process when executable file loaded into the memory. If not executable, so it is a program. If it's executable, means it's already load the file into the memory, then we call it as a process. So that is different between program and the process. So program is more on the passive, just a program stored in the disk, but process when you run the program. Okay. So execution of the program started via the graphical user interface, mouse click. So it's based on the graphical interface. Either you use a click, you use gesture, or you use touch screens. It depends on the hardware that provided to the users. Okay, you can recall back the architecture of the operating system, that you know that we have the interface, user interface, before we go for the user. So depends on the user interface that available. Okay, one program can be several processes. Okay, this part is considered multiple user execution the same program, so it can be several processes. Okay, you need to remember again what is the program and what is the process. So this it look like, okay, based on the previous slide, okay, based on this slide, okay, we have stack, data, heap section, we have heap section. So this one is look like your memory, process in your memory, in computer memory. It's not in your memory, but it's a computer memory. Okay, so we have the stack. So this section contain the temporary data. Okay, this one is your memory, and then we have the heap that global contain the global variable, and then we have the heap for the dynamic data, and then we have data for the global variable, and then we have a text for the code, program code, and also text section. Okay, this one refer to this slide. Okay, so and this one is the address. We have 0 until the maximum numbers of your memory address. So it look like when you do the programming and we play around with an array. So in array we have the index. So index must start at 0. So the same goes to our so the same goes to the computer's memory. Okay, it has the index in order to identify the location. Okay, so done for the concept of the processes. Okay, the next part we go for the process state. A process state is the process of execution. Okay, as a process execute, it change state. I mean, from it's just like when we want to develop something, we based on software development life cycle. So we have state for the planning, and then after done with the planning, we go for the design. After done design, we go for development. So the same goes for the process in the operating system. So it has state. So we have new, the process is being created. Okay, we create, so state new, and then running, instructions are being executed. Then waiting, the process is waiting for some event to occur. Ready means state ready, the process is waiting to be assigned to a processor. And terminated, so the process has finished of the execution process. So we have new, running, waiting, ready, and terminated. So that are the state in the process execution. Okay, the next part, let's look at this diagram. So the diagram of the process state. Okay, this is the state. We call it as a state diagram. if you learn about you are the computer science student. Okay, it's state the diagrams. So means where it begins and where is end. Okay, so this shape refer to the state, and this refer to the process. Means here we have state new, so admitted to the ready, and then when ready, schedule this page is go for the running. Okay, look at the arrow. Okay, this one to this one, this one to this one running. So after running, it can go for the waiting. If let's say it involve the input and output or even wait, so it need go to waiting. Waiting after the event completion is go to ready. After ready, go to running. After run, it can exit by the terminated state. If during the running process then being interrupt, so it needs to go back to ready again. So this is what we call as the state diagram of the process state. So we have the new, ready, running, waiting, and terminated. Okay, the next one, the process control block or PCB. So you can look at this block. So the information associated with each process, also called the task control block. So we have the process state, running, waiting. Okay, process state refer to this one. Process state, we have new, ready, running, waiting, terminated, so on. And then program counter, the location of instruction to be next execute. Okay, we call as the program counter. Then we have the CPU register, content of all process-centric register. And then after that, we have the CPU scheduling information. So this CPU scheduling information is do the scheduling process for the priorities, first in, first out. Yeah, scheduling queues, pointers at this process. And then we have memory management information. So this memory allocated to the process. Okay, when we run certain process, so the memory management need to allocate amount of memory to that process, so that process can be run in your computer system. And then we have the accounting information. So the CPU use clock time elapsed, scene start, and time limits. So it's based on the information status and so on. And then we have the input output status information. So input output devices allocated to process, list of open file. Okay, done for the block of PCB task control. So it's like this one. We have the process state, we have the process number, process program counter, how many process involved here. And then we have the registers to store at the centric part. And then we have the memory limit, allocation of the memory for each process, and then we have list of open file in order to run that process. So these are the information that associated with each process. Okay, the next part is show the diagram on the CPU change from process to process. Let's say we have multiple process that run in our CPU. So the process will change from one process after another process. So basically it begin with the process 0. Okay, process 0 in 0. Okay, so this one we have process 0. So after process 0 done, then it will execute process number 1. So the process will be execute here. And then it will receive state into the PCB. Okay, process block. And then at this part is idle. It will reload state from the PCB. Okay, interrupt again. This one execute. This one for reload the state from the PCB. So save, execute process 0. Okay, so save state into PCB 0. Idle. Then process P reload state from PCB 1. Okay, execute at here. Okay, this one execute and then idle. So we can execute process 1 at this point. And then save state into PCB 1. And then you can reload the state from PCB 0. So you look at this diagram. Process 0 execute, then idle. So during the idle time, the system call can run another process or reload another process, which refer to process 1. So when the process 1 idle, means it shift to the PCB 1, then the system call of the operating system can reload the PCB 0, means the process 0 again. So it's begin the execution process. So this is how the processes change from one process to another process, means how the computer system change from one process to another process. Save and then reload. Okay. The next term we have the thread, and this thread we will learn more on the chapter 4. So far the process has a single thread of execution, and consider having multiple program counters per process. So multiple location can be executed at one time, and multiple thread of a control more than thread, means we have multiple thread. At this point, we have considered as a process that has a single thread. So later on we look more on the thread issue, multiple thread, single thread, and so on. So we need to have a storage for these thread details and multiple program counter in the PCB. So later on we will discuss about the thread under the chapter 4. Okay, next is the process representation in the Linux. So at this point we will continue on the next video. So basically at the first video, you already know about the process and the concept in the operating system. What is a program? What is the process? How to differentiate between the program and the process? Okay, how the process of change from one process to another process. So later on, we go more on the process representation in the Linux, in the operating system. So thank you, and Assalamualaikum.